6-3 day 1. I forgot to do these 2 slides. Here's what it is though. Okay, yesterday I talked about something called the common log, right? Well, the common log meant you're in base 10. Thank you. Okay. Now this is so common, you can type this into your calculator. So log of 1,000. Do you know it, or do you need to type it in?
Is it log 2, or is it 10 to? 10 to the second?
Nope.
10 to the third.
Yes, but the answer is what? The answer is 3. Because what is a log? A log is an exponent. You're supposed to be thinking, oh, 10 to the third is 1,000, so the answer is 3. If you type it into your calculator will tell you 3. You don't even need your calculator for that one, but you would need it if I would have said, let's do this one. What's the log of 1,080 base 10? It's more than 3. It's probably 3 point something.
3.0334.
0334?
Yep.
Okay, so there's the answer. But you couldn't do that. You needed your calculator. Now, here's another one. It's not called the common log. It's called the natural log. The natural log, if you guys remember, when I did exponential, like when money grows continuously or something grows continuously, we brought this number in. The number was E. Remember PERT, the formula PERT?
Yeah.
Okay. So here it is the common log. It's right here. It is base E. So they're saying if you have log of x base E, then it's going to be the same as the natural log of x. Now, they couldn't call it log because log was already used for base 10. So they said, let's call it natural log, and then for some reason they go ln. But this is the natural log of x base E. It will do anything you want it to do, like for instance, oh, by the way, the natural log button is right next to log, right? Yep, okay. So it is base E. So if I said 10, can you just do it for me, please? What's the natural log of 10?
2.30.
2.30. Okay, so here's what it's telling you. It's telling you if you took E to the what power?
2.30.
Okay, you wouldn't quite get it, but you'd get what?
10.
You would get just about 10. And you can double check it. I'm sure it is close to 10. Okay?
Yeah.
That's all it is, guys. There's a common log, base 10, log, and there's the natural log. The natural log is ln. It's right next to the log button. That's it. That's all you have on your calculator. So if you had base 3, couldn't you do base 3 with your calculator? Is your calculator programmed for base 3?
No.
No, you can't do it. But after today, you can.
We're
All right.
gonna-
All right.
We're gonna use the math button.
Yeah, well, I'll show you. Ready? Do that one for me right now.
Pull.
What's the natural log of 7, guys?
1.94.
1.94, and that's estimated, I think, right?
It's 9.5. It's 9.5.
9.5?
9.6 or 4.6, I'm sorry.
Okay, so we'll go a little higher, 9.5. Okay, this one, no calculator needed. Please don't even touch a calculator. Ready? Natural log of E. Remember, we're in base
1.
E, what?
It's 1.
Because E to the what?
First power is E.
Is E to the first power, right? Okay, so you don't need your calculator, all right? On some of them. On some you do, okay? All right, that's it for day 1. Done. Now, see, it would have been a little easier to finish your assignment yesterday if I would have just said that. Okay, now I'm done there. Okay, now I'm here. Nope. Don't say. Okay, now I'm going here. 6.3b, guys. There's your answers from yesterday, but we'll just continue. All right, here we go. So, what's this one all about? Properties. Okay, here's the deal. I'm just going to have to, guys, I have to show you the properties because for you to be successful in 6.4, 6.5, 6.6, you got to know your properties, okay? So it's kind of one of those days where you go, properties, really? Yeah, really. But I'll try and make them make sense to you. I don't want to just tell you the properties because if I just do that, all you're going is, oh, he said this and this. Well, let's look at it. All right, ready? The first property basically says this. If you take the log of 1, base A. Base A means any base you can think of. Oh, sorry. A has to be what?
Greater than 0.
So positive. A can't be
Can't
what?
be 1.
Can't be 1. Okay. Anyways, so the log of any base of 1 is always equal to what number? 0. Does this make sense? Well, let's do this. Here's what I recommend you do on every one of these. Put numbers in instead of letters. They're saying this. The log of 1, base any number. Give me a number.
3.
3. I heard 3. Okay. Has to equal what number?
0.
Ah, is this true? 3 to the 0 equals 1.
Yes.
Is that true?
Yes.
Well, you say yes, but here's the thing. Back in Algebra 2, they told you any number raised to the 0 power will always be what? Yes, so it is true, okay? Guys, I'm just trying to show you why it works, okay? Don't start yawning on me yet, because the yawn tells me you're getting bored, and I understand properties are not that fun. Okay, ready? Here we go.
You said the word yawn, so
Now you're gonna yawn, don't yawn. All right. Okay, these two, right here, these two only work because
they're inverses.
they're inverses of each other. Now, here's the deal. I'll show you what I mean by inverse. This one says log base A of exponential base A to the k. So you've got a log and you have an exponential. Both bases are A and A. Guess what? The answer is what? The answer is right here. It's k. Now, why does that work? Okay, watch this. Log of, let me think of one. Okay, let's go like this. 5, log base 5 of 5 to the second power. What's the answer supposed to be? 2. It says it right here, guys. Log base A of A to the k is k. Is it true?
Yes.
Well, let's just,
the square root of 5
Yeah.
squared is 5.
let's go across here. Well, no, let's just slip down here. Okay, what is 5 squared?
25.
So really this says log of what? 25 base 5. And then what's the answer going to be?
2
Yeah, 5 to what power?
squared.
2. 5 to the second equals 25. You okay? All right, okay. Now this one. This one says exponential base A raised to the log of base A of k is equal to k. So this is the answer right there. All right, check it out. Let's do, come on over here, please. Let's go 10, raise it to log base 10 of 100 equals. What's it equal? Yeah, it says right here. Exponential base A raised to the log base A of k is k. Well, okay, so they're telling me the answer is what? 100. Is it? Well, let's do it little bit by little bit. Ready? So what is the log of 100 base 10? Just look here. What is this?
Oh, I get it. Then 2 times 10 is 100.
Wait. What is log of 100 base 10?
2.
Yeah, 10 squared is 100. So yeah, you're right. 10 squared is 100. But 10 squared is what?
100.
Ah, it does work, right? It works. Okay, now go back here and look at what I just wrote you. I said these two are inverses, correct?
Yes.
Okay, when you see log base A of exponential A to the k, here's what you can do. They undo each other. The answer is what?
Okay.
K. This one, exponential base A raised to log base A. They're inverses. Cross them out. What's the answer?
So do we actually have to show any work then? Or
No, that's what my point is. My point is you don't have to show it. You just need to know your properties. Okay, are you buying into this?
Yeah.
Okay, because that's more important to
All I
me
know is
that you
no.
buy into it, because if you don't buy into it, then really I'm just telling you a bunch of junk. Hang on, my cord came out. Okay, these are the three. Hey, these are the big three. These are the ones you got to know, okay? This one says log of x times y base A is the same as what? If you multiply two numbers, you can actually split one log into what? 2 logs, as long as you do what in the middle?
Add them.
Add them.
Don't the bases have to be the same?
Yeah, A, here, they're all the same. So let's just do one, ready? what is this? Log of 10 times 100 equal to log of 10 plus log of 100. Okay, now because I did not put a base, what base am I in? 10. All right, everybody, let's prove it works. Ready? What is 10 times 10, or sorry, 10 times 100?
10,000.
Not 10,000.
1,000.
Isn't it 1,000?
Yep.
Yeah, 1,000. Okay, cross that out. All right, will you tell me this? What's log of 1,000? What exponent? 10 to the third power is 1,000 equals, what's the log of 10? 1. 10 to the first is 10 plus, what's the log of 100? 2. 10 to the second is 100. The answer is always an exponent. 3 plus 3 equals 1 plus 2. True? Yeah. Boom, it works. That's what I'm trying to tell you. You got to see it works or else you don't believe it. All right, log, base A, of x divided by y is equal to 2 logs subtracted, right? So division goes with subtraction where multiplication goes with addition. All right, you ready? Let's prove it works. Here we go. Log of 1,000 divided by 100 is equal to log of 1,000 minus log of 100. Is this true? Well, what's this, guys? What's 1,000 divided by 100? This is really 10. So what's log of 10?
1.
1 equals, okay, she said 10, or Allison said 1. Are you guys agreeing with her? You're okay with this? Log of 10 is 1. Log of 1,000 is what?
Is 3.
10 to the third is 1,000, yep. Minus, log of 100 is? 2.
Yay, we did
Would
it.
you agree that 1 equals 3 minus 2? Yeah, okay, it works. All right, we're ready. This is it, last one. So if you take the log of x to the r, base A, it is the same as r times log of x, base A. This r goes where, guys?
To the front.
In the front. That's what they're trying to tell you. So if I did this, log of 10 to the second equals, okay, what would this be, guys, over there?
2 times 2 in the front.
2 in the front,
Log.
and then log of 10. That's what the property says. Is it true, though? Well, what is 10 times 10?
100.
Yeah, so this really says, right here, this really says 100. What's the log of 100? 2. So 2 equals, ready? On the other side it says 2 times, what's the log of 10?
1.
1.
2 times 1.
2 times 1, yep.
So
2
2
equals
2.
2, check, it works. Okay, you get it? Does it work?
Yeah.
Yeah. Now, guess what? You have to trust it works. You just have to trust me. Because now, everything we do is basically these properties, all right? Here we go. First, 5 problems. Use the properties to rewrite all of these. Now, here's the deal. I didn't write this word, but I think next year I probably should say this in your notes. Expand, which means take a log and make it longer. So 2 logs, 3 logs, okay? That one says log of 8 times x. That's multiply.
Log of 8 plus log of x.
Okay, so multiply can be split into 2 logs as long as you say log plus log. Okay. What base am I in?
And
Then you don't have to write 10. So what are you going to put first? 8. And then what? X. And that's about all you can do, guys. Next. Division, log, base 9 of 15 divided by 7 is this. What are we going to do? Add, subtract?
Oh, we're gonna subtract.
We're
Log
subtracting.
9 of 15. Log base 15 of 9. I don't think I said that right.
Okay, hang on one
Base
second, one
9
second.
though.
So it is
Base
subtraction.
9 of 15.
Which one goes first though? 50 or
15.
numerator first, denominator second,
Wait, do we have to
base
put the
9,
Oh, we do have to put
base
base.
9. Now,
If they
if
have the
it's
same base but it's not 10, you want us to put the base.
Oh, yeah. So 10 you don't have to put because it's called a common log. But if it's not anything but 9 and E you don't have to put.
Okay.
This one doesn't look like multiplication, doesn't look like division, so it must be the last one.
Yes.
It's an exponent.
Yes.
So this would be log base 5 of 8
Raised to the 1/2.
raised to the 1/2.
Should be.
Chapter 5 said square roots, cube roots. You can rewrite them. Okay, where are we going to put the exponent?
The exponent
Oh, at the beginning.
In the front, yep. So it's really the
1/2 log
same as this, right?
Base 5 of 8.
Okay. And if you kind of look at these three problems, they basically went over property 4, property 5, property 6 on the previous slide.
Isn't D just 3?
Okay, now hang on. Now we're going to D. And D, you can think about it really, really hard, or you can just trust your properties.
3.
That's exponentially 2 to what power? 2 to the log base 2 of 3. These are inverse operations. They will cross out the answers. What?
I think we missed something in the last one because it was log to the 5, like log 5. and then-
Oh, did I miss a base?
You
Oh, my base is not there. Yep, you're
Wait,
right.
so how does that expand it?
That one?
No.
Or that one?
No, D. That's not expansion.
That's not an expansion, you're right, but that's one of your properties. That's what they're trying to say. If you get this look, just don't think too hard.
It just doesn't.
It's,
It's not so bad.
there's nothing to do other than just say the answer's 3.
Okay.
Yeah, there's no, because this doesn't say log of multiplying, log of divide, or log of a number to a power. This is one of those first 3 properties, okay? All right, this one?
Log base A of X minus log base A of YZ.
Okay, so you see division. Division is the same as subtraction, so you know it's log minus log.
Wait, do we need to do like
Numerators first, denominators second. Good?
Do we have to expand it more?
But, yeah, once you do the first thing,
Yeah,
then
you forgot the base of A.
once you hang on. Once you do the first thing, then look at what you have. You still have multiplication going on. So yeah, I did forget my A's. A. So this is the one you got to concentrate on right there. You have log of multiplying. Well, that's going to do what? Turn into what?
Addition. Well, you should put it in parentheses, right?
Okay.
Or not?
No, hang on. I'm catching up to you. It's log
Base A
Plus
of Y
log
plus
base
log
A,
base
base A,
A of Z.
Y,
Let's
and
see.
Z. Now the thing is, it did say take log of X minus whatever that is. And whatever that is, it turned out to be a binomial. So yes, you do need grouping symbols. You have to tell me you want me to subtract that number and subtract that number. Now, if you quit here, guys, if this is where you quit on the test, I'll give you credit as long as you have what? You got to have the parentheses, right? Okay, now, some students will say, well, that negative, I can run it through.
Oh no.
I can run it
Who said
through,
that?
and it just be log of what?
Log base A of X minus log base A of Y minus log base A of Z.
Okay, so, just so you know, put a star here, put a star here. They're both right. I'm just trying to tell you, if you quit one step early, you've got to have that grouping symbol, because without the grouping symbol, you basically are telling me to subtract this log and then add that log, and that's not right. Got to have your grouping symbol, but if you distribute it through, that's fine too. Nick, eyes open. I know you're dreaming about math, I can tell, but keep them open. All right, now, this one. Write each as a single log. Well, single log, another name for that would be
Reverse the property.
condense. So condense means make it shorter. So when you say 2 logs or 3 logs, make it down, just get it to single log. I just want 1 log in the end. And you can only touch 2 logs at a time. You can't go, oh, look at all these log. No, 2 at a time.
Log base A.
1 second here, I gotta ask you this. Whenever you see this and this, these are called what?
Negative.
What? Those are coefficients.
Nope. Well, kind of yes, but the number times log
Exponents.
are exponents. Where do they belong?
At the end.
On top of the number you're taking the log of, right? So we have to say this is the same as log of
A base
M.
A of m squared minus log base A of n cubed.
Okay, so try do this. Look for the exponents. The exponents in front. Move it up on both of them, and then you can start. You got subtraction in the middle.
So is that? Does
So
that make it
subtraction
negative?
would come down to 1 log.
Oh, so it's division.
It's division. Subtraction and division go together. So let's slide over here. Log base A. It's now division because you went to 1 log.
Log
First
base
number
A
is the
m squared over n cubed.
numerator. Second number is the denominator. So m squared over n
Cubed.
cubed. Now just try listen to this. When you get done with this, you have 1 log. You have to look at what you have the log of. You have basically log base A of this number. If this number is reducible or could be simplified, do it. Well, you got an m over an n. Can you do that? No. But if you would have had m to the 5th over m to the 2nd, I hope you say log base A of.
And then there.
Yeah, I mean, this is what I'm trying to tell you.
Yeah.
If you can keep going, just keep going. Because this is what you're going to see in the back of your book. Okay? Good? Okay. All right, this one. Log, I always look at it and go, log plus log minus log. Okay. The first 2 logs are addition. Well, addition means push them together, make 1 log of what though?
2x, or x squared plus 2x.
Okay, but tell me what addition goes with what operation?
Multiplication.
Multiplication, yeah. So it's log base 3, and then it's going to be that number times that number, right? Because you got to distribute through x squared plus 2x.
Mhm.
Okay, so
Minus.
just do 2 at a time. You did 2 at a time. Now throw on the other one. Okay, now you have subtraction, which we should know is what?
Division. So it's
Division.
log
Okay.
base 3, then x squared plus 2x over 2.
Numerator, first number. Denominator, second number. How do you know you're done? Or are you not done? What?
You can't reduce it anymore.
Can't reduce it anymore?
No.
Okay. How do you know?
Because 2 and 2x aren't the same thing.
There's nothing to divide by.
There's nothing what?
To divide by.
Well, I can divide by 2.
There's no,
They don't have anything in common.
They're not like terms.
Yeah.
What?
They both have to be factors.
They both have to be factored before you can cancel. So you know what? This is what you should have thought in your head. X squared plus 2x is really, if I factor out an x times x plus 2. Well, this is a monomial x. This is a monomial 2. X and 2 are not going to reduce out. This is a binomial. Binomials and monomials can't be touched. You are done. Yeah? Okay. So just really quick though, if the answer would have been this, let me go 2x squared plus 4x. Would
Take
I
out a 2.
would I be able to keep going?
Mhm.
Yeah, because you would hopefully take out a 2x, right? And get what?
X plus 2.
X plus 2, and then you go, that's gone, that's gone. Now the answer is log of,
X squared plus 2.
or you could just leave it like that too. I mean, that's okay too. But you gotta be careful when you start reducing. Okay, whew, what a mess. And it is a mess, by the way, so be careful. Here we go. Look at the numbers in front of log. I got a 1/2.
Those have to go and be the exponents.
Okay, so
So it's
this would
m
be
to the
log
1/2.
base b of m to the 1/2 plus log base b of,
2n to the 1 or 3 over 2.
okay. Now, what's being raised to the 3/2?
The 2n, the n.
Well, remember you're taking the log of this entire number.
So 2n.
So this goes up here, doesn't it? So it's going to be log of 2n. But you guys, when I write, if I write it like this, do you understand that it means take 2 and raise it to the what?
3 over 2 power.
I mean, these are just ones, aren't they?
Yeah.
So it's power raised to a power. You multiply, and really this would be log of what then? 2 to the 3/2 times n to the what?
3/2.
Okay. And of course back here you have log of what?
B.
M to the 1/2. Oh, minus log of b, base b. Nothing, right? Yeah, there's nothing there. There's no exponent. So, okay, I took care of the exponents. That's the first thing I did. Whew. All right. Take care of the first two logs. Log plus log is the same as
Multiplication.
multiplication. Take two of them, make them one. So it'd be log of base b. 2 to the 3/2, I'm just going to leave it, times m to the 1/2. Okay, I guess there's no more. N to the 3/2. Okay, I guess there's no more. Minus log of m squared n. Are you okay? Now, you got subtraction.
Log
Two log subtraction is the same as one log
division.
division. Okay.
Log
So-
base b.
log base b.
M to the 1/2.
Okay.
And then
Yeah, 2 to the 3/2. M to the 1/2. N to the 3/2. Divided by m to the second. N to the first. And this is what I meant by yuck. Okay. Okay, now, try to understand this. This is a monomial. You don't see any pluses or minuses. This is another monomial. Monomials, they're easy. You just divide them out. So, I don't see a 2 down here. So this one's done, right? Log base b of what? 2 to the 3/2. Okay, times.
1/2 minus 2, which is negative 1/2.
Okay, so you're going this way, I see. You're going 1/2 minus that number 2. That'd be n to the,
M. M
oh, m.
to
m to the
negative 1/2.
negative
3/2.
3/2
Yeah. So then you need
times
to
n
to the 1/2.
to the 1/2. Yep. Okay. You guys following that or not? I'm just no, Quinn. Okay, Quinn. Just if I go like this, you have to remember that if I give you easy numbers like this, you just basically subtract, don't you?
Yeah.
The answer is 2, right? 5 minus 3. Well, that's what we're doing here. There's a 2 here, but there's no 2 here. That's why this one didn't change. M to the 1/2 subtract the 2 is, I didn't do the common denominator thing, but it is m to the negative 3/2. 3/2 minus the 1 down here would be 1/2. Are you kind of with me now?
Yeah.
Okay. Now, here's the kicker. They're not going to write the answer like that. You know what they're going to do? They're going to go like this. Log base b of, ready? You're supposed to take the 2. This is the root. Correct? This is the what? That's the root. That's the
The
power. And see, they're going to, you remember how we used to wrap it and put 3 out here? But they're going to do that. They're going to put the 3 inside because that's easy. That's really the square root of what? 8. Okay. Times the square root of what? Oh, hang on 1 second. That's a negative exponent. So it's going to be on the bottom. It's going to be on the bottom, I guess. Square root of m to the 3rd. This one is going to be square root of what? N.
Do we have to write them?
No, I'm trying to tell you this. This is what the answer is going to look like in the back of the book. They'll probably put an 8 here instead. This will probably just be 8. And because it says square root of 8 times square root of n, the whole thing's gonna probably say the square root of what? 8n over, whoops, oh, sorry, I meant to do this.
Do
Okay,
we have to write our answers like that?
no, I'm not telling you that, I'm just trying to tell you this. The book is gonna keep going and going until they get here, and you guys, I'd be super happy. Right here, right there. I mean, if you get to that point, guys, you did all your exponents just fine, and you did it all. You got your exponents. I'm not going to get so worried about, can you guys change this to log of this? It's not even worth it. All right, I'm happy right there. I think if you look in the back of the book, you'll go, oh, yeah. The square root of 2 to the third would be the square root of 8. I think you'll figure that out when you look at it. Okay? There's only a couple like this in your assignment. I just wanted to show you one of them. Okay? I'm done.
That's all we're doing?
I think so. Isn't it? Oh, there's a change of base one. Change of base. Super simple. Super simple.
Not doing logarithmic functions?
That's the next lesson. I forgot to put 6-4 on there. Okay, we're done. Okay, here's the deal. This one. This is the last thing you have to do in the assignment today, and that is change the base. Here's why. Because sometimes you can't do this. Log of 17 base 5 equals what? Well, wouldn't that be
5 squared equals 17.
5 to the
5
x
equals
equals 17.
And you can't
Now
do-
remember, I said try get the bases to be the same. Can you make 17 base 5? Nope. So now we're stuck. Okay, we are now what?
Stuck.
Okay, but no, we're not. We're not stuck. There's something called change the base. So the change of base rule says this. If you can't do this, and by the way, you have no base 5 in your calculator. They say this. If you can't do this problem, then do this. And they're telling you to change the base to base what? B. Change them both to base B. But what base would you change them to? The one in your calculator. Base what?
10.
10. Or? E. You have natural log, you have common log. Okay, so here's what they're saying to you. They're basically saying you just take log base 5 and change it to log base what? 10. Log base 10. And whatever this number is here, here, that goes on top. Whatever the base is, that goes on the bottom. And that's what we're going to do. So what would our two numbers be? Look back here. 17 on top. And 5 on the bottom, right? Log of 17 divided by log of 5 should give me that answer. Okay, now you got to type it in though. Nick, type it in. You're just too stagnant right now. Come on. You guys aren't doing anything. You got to do something. Type. What are we getting?
1.3859.
1 point what?
3859.
3859. Okay, that'd be 6,
I
wouldn't it?
got 1.76.
Okay. Oh, you get what?
1.76.
76. Okay. All right. How do you know you're right?
Plug it in, check.
Well, right here. This is what it means. 5 to what power? 17. Put your answer in. Put that one in. Or you guys got this one. Put that in. Which one actually gives you 17?
1.76.
Oh, I didn't put parentheses, that's all.
Aha. So there it is. So what it is, guys, is this. When you type this in, make sure you go, what's this? Put parentheses around it. Tell the calculator. Figure out what that is, then divide that by what's this. Okay? Or, you don't have to do that either. You could do log of 17, hit equals, get an answer, divide that answer by log of 5. And it works too. No parentheses needed then. Did you get it? Okay. Did everybody get it?
Yeah.
Which one was it, by the way?
1.76.
Okay, so there it is. It's that one, guys. All right, that's it. Change of base is so simple, right? So, guys, if I gave you this on the test, what's the log of 72 base 8?
We're gonna change the base for 210.
Yep, so go what?
Log base 10 of 72 divided by
Log base.
10 of 8.
Okay. Or, hang on. There's another way to do it. You don't have to
log
change it.
base E of,
No, it's not log. It's called natural
no,
log.
natural log of 72 divided by
Natural log of
natural log
72 equals what? Or over divided by what?
divided by the log, natural log of 8.
You should actually do it and just prove to yourself this and this are the same thing. They really are. It's just, you just have to pick the base that you want. You want an E? Go with an E. You want a 10? Go with a 10. It doesn't matter. Does anybody have the answer to this? 2.056. Did they both give you that though?
Yeah.
Yeah?
Mm.
Okay. So it works. We're okay. This should be the easiest problems I gave you on your assignment, right? I hope. Okay. We are done.
Can you go back to the last one real quick?
Yeah.